Hello, hello! Welcome to the stream! David Snowpeck here from Snowpeck Games. How is everybody doing? I see Ricardo is here. We both got relatively boring characters on the overlay. Ooh, Nionel is here! How's it going? What's up? Alright. It's been so long. I feel like I don't remember how to stream. You guys will have to help me remember. Oh, come on. And I got to get our overlay to go into overlay mode. I got to remember the buttons for that. Here we go, there. Oh, cool. A whole bunch of people showing up today. Welcome, Justin Cornell, Daniel Naratelli. Yeah, the streams are supposed to be on Fridays. I missed the last 2 weeks for just crazy reasons. And I was gonna have to miss this Friday too because it's Thanksgiving week this week, which generally, Thanksgiving's on Thursday, and generally everyone is also on vacation doing family things on the Friday. Okay, are the stream tools going? I hope so. So anyway, I moved this one to Wednesday so that I wouldn't skip 3 weeks in a row because that would be crazy. That'd be way too many skipped streams. Yeah, so it's great to be back. Great to see all these folks here. How are you guys doing? How are your projects going? I haven't gotten any project updates from you guys in 2.5 weeks either. By the way, since I say this every stream, the stream overlay that we have going on right now, hopefully it's actually working. Let me know if it's not, is a Godot game that we built on stream sometime back. It integrates with the Restream API so that we can get the little characters and the chat bubbles on there. Nionel says sometimes you got to take a break. Yeah, I didn't really want to take a break right then, though. There was so much stuff going on. This last time, this past Friday, I was sick, and I still am a little sick. So I apologize if I break out into uncontrolled coughing. I'll try to get the headset off so you guys don't have to listen to it. But I'm feeling better. I'm feeling better today, so that is good. Now asks if it was COVID. So I don't think so. My daughter did test positive for COVID a week before last, so it's not impossible that it was. But I got tested like 6 days after she was positive, and then I took another test on Monday just to make like double extra sure. And it's this 24-hour test, and it's supposed to come back, in less than 24 hours, and I still haven't heard after 2 days. So like after the stream, I'm going to call him and be like, hey, where's my test yet? But I don't think it is. I mean, if I tested negative the first time, I'm expecting the second time to be negative also. If it is positive, then I have another like 2 weeks of insanity off to quarantine again, and not looking forward to it. Yeah, so she was actually pretty much fine. I've spent like 1.5 years being terrified of coronavirus, and then my daughter gets it, and she was real sick for 1 day. And then she was better after that, and it was just a little bit like, tired and sniffly or whatever for the rest of the time. So we got super lucky. My other daughter tested negative for it. My wife hasn't had any symptoms, also tested negative. So like we got super lucky. We were super lucky. So anyway, I saw Ricardo made a Game Jam game. Let me bring that up on the screen here. Frogalita. Frogalita. Frogs going. Oh, I think I actually remember you talking about this game, or maybe the game idea? Someone was talking about a frog game. It might not have been you. It might have been something totally unrelated. I do remember there was a stream where someone was talking about a frog game. So I didn't read the instructions. Ooh, it's one of these. Ooh, okay. Stretch to pull. Can I eat the bugs? I would very much like to eat the bugs. I am a hungry frog. Wait, do I avoid the frogs, or are the other frogs good? They have hearts in their eyes. That might denote good. Nope, not good. Whoa, they're bigger than me! Okay, I did not read the instructions or anything, so I don't know what I'm supposed to be doing. But it looks cool. I like the ooh, admire. Oh, I'm here to collect admirers. Interesting. Let me go read the description. So what is the idea here? Frogalita, jump on ever-changing lily pads, catch elusive dragonflies, avoid annoying admirers. Oh, so am I supposed to avoid the admirers? I'm a little bit baffled here. So, okay, so I have an increasing number for fireflies. Numbers that go up are generally considered good in video games. And I have a meter here of heartness. Ooh, okay, so they sapping up my heartness? What was the theme of the jam? Let me see what the Godot Fire Charity Jam. Big prizes. Everything changes. Interesting. Well, I dig it. I dig it, Ricardo. What else is going on? Gauntlet. Hey, Gauntlet. Made some progress in the past week developing templates in GDevelop. Cool. Yeah, GDevelop is another game engine which seems interesting. People make lots of cool stuff for it very quickly. Hey, Thed. How do you make rollback netcode in Godot? Good question. So we've been working on stream for the last, like, I don't know, too many weeks. Like 3 months worth of weeks, maybe even 4 months at this point, on implementing rollback and prediction netcode in my game Retro Tank Party. So I guess this is the moment where I should explain what the project is that we're working on here. So Retro Tank Party is this 2 to 4 player online multiplayer party game where you shoot your friends in tanks and get power-ups, and it's fun. The version of it that's available on Steam and itch right now uses relatively naive netcode, but we have been converting it to use rollback and prediction netcode as popular in competitive fighting games, and the GGPO library and those sort of things. And we're pretty close to actually finishing it. And the plan is when we finally have this game fully done and it's released, I'm going to take the asset that we've been building, this little library for implementing rollback and prediction in Godot, and put it on the Godot asset library. And I'm going to make tutorials for it and all the usual stuff. Unfortunately, like, if you're sort of looking for the beginning of, like, how would I do this in my own game, this stream isn't going to be a good stream for that, because I'm not going to go back to the beginning. We're just going to keep working from where we left off. But all of the streams are on YouTube if you're curious to kind of check that out. And all the code is available. It's all open source, so you can go look at the code right now if you want. But yeah, so it's been a while, like we were just talking about, since my last stream. And I have gotten some stuff done since the last stream, although not nearly as much as you would probably expect. I haven't been putting my normal obsessive focus into game development because of the craziness of the last bunch of weeks. But let me show you, folks, what I have done in the meantime anyway. So I fixed a bunch of bugs. I don't know if you guys remember from 2.5 weeks ago on the last stream, there were a whole bunch of state mismatches that were just like all over the place. I had gotten the state mismatches down to a very small number, and then we kind of had an explosion. So I fixed that and a number of other bugs. The whole state mismatch thing, to give a little bit of background, the way that rollback and prediction netcode works is everything has to be deterministic, and you're only just playing the inputs on each of the clients. So you'll have, everyone will connect to the game, they'll all start at the same state, we'll exchange our inputs, and it's kind of expected that if you're applying the same inputs on the exact same state of the game, you'll get the same resulting state. And when the state doesn't match on 2 clients, that is a state mismatch. And there was a whole bunch of debug code in the asset, the sync manager here that does all of the rollback and prediction stuff for us. For comparing the state, basically all of the clients were sending the state back to the host. One peer is always picked as the host. They don't do that much. There's not that much special about the host, but there has to be something to kind of disambiguate these handful of scenarios where like a singular decision needs to be made. Anyway, they send all their state back to the host would compare it and say, there's a mismatch. So that was what we had before. One of the other things that I implemented in the past 2 weeks was the sort of like production version of that. The debug version was, like I just said, sending the state, the whole state, which is actually pretty big, from the other clients to the host. But we do need to do these kind of checks, not in debug mode, but when the game is normally being played. And that version is just sending these hashes. It's taking a hash of the state. All of the peers are sharing them with each other and checking to see if the hashes don't match. The hash is just a single 32-bit integer, so it's really fast to pass around. I have it being passed in the normal input messages along with the input. And basically what it's doing is it's sort of saying how many state mismatches have we seen in a row, because while in a theoretically ideal world there would be 0 state mismatches, as we've kind of seen in practice, getting rid of all those state mismatches is hard. And if the state mismatch only happens like on 1 frame or 2 frames, like it's usually probably fine. A fatal state mismatch would be like if the score was wrong, right? If one client said the score was 1-2 and another said it was 2-1, that would be wrong every single frame. We'd get a state mismatch every frame, and if that happened, then of course we have to bail. We can't keep that game going, like something went terribly wrong. So this kind of idea, I think I have it set to 10. Find the variables at the top here. Max state mismatches. Yeah, so if 10 state mismatches happen in a row, we can't continue the match, and it just bails out. And of course, when we launch the game, we're going to have things debugged to the point that hopefully that will never happen. The Gauntlet asks, when you create a peer-to-peer net game, how do you solve the issue of host having 0 ping and another having higher ping? So, good question. There are a bunch of strategies. So we're using, I think, the same strategy that GGPO is using. I got it from this article. Geez, what is that game called? There's this great article that was on, man, my brain is just blanking on everything. What is the site where like all the game developers' blogs are aggregated? I'm just having like the worst brain lapse here. It's got a green color scheme. You guys know what I'm talking about. Hang on. Let me go. Let me go look in my like RSS feed here. Kamasutra, on Kamasutra. Okay, so I read this article on Kamasutra from a game developer who made a rollback and prediction game, and he described this system of calculating the advantage, and the advantage is how many ticks ahead the other peers are to you. So the way this works is you are never you never have the other peer's data for the current frame during the current frame. You're going to get it sometime later because there's always some amount of lag. And when you don't have their input, you're predicting frames. You're predicting ticks. And so let's say you're predicting 2 frames for them, and then the delay is higher for another peer, and they're predicting, let's say, 4 frames, right? Or no, actually, back up. Let's just deal with 2. Let's just deal with 2 clients. We'll just say 1 peer and another peer. Maybe I'll even draw a picture for this. So we have peer number 1, which is going to be this random blob. No, let's not do a random blob. Let's do a square. Squares are nice. So we have peer number 1, and we have peer number 2. And so let's say we're predicting 2 frames. Let me move that. So it's taking 2 frames for this peer's input to arrive to us, and it's taking 4 frames for our input to arrive at this other peer. So kind of the idea that one has a low ping, another has a high ping. We would say in this case, from the perspective of peer 1, what would the advantage be? We are predicting 2 frames for them. They are predicting 4 frames for us. So we actually have, we'd calculate an advantage of -2 on this side and an advantage of 2. Anyway, you end up making these advantage calculations between every peer. So, peer one would also come up with a separate advantage calculation for peer 3. And you would take whatever the max advantage is, and if it's over a certain amount, I think in our game we have it set to 2, the advantage is over 2, then you will skip a frame to allow the other peers to catch up. And by skipping a frame, you're also going to change the advantage between you and the other peers. But the way that this works in practice is actually really cool. If everyone is doing the same advantage calculation and skipping peers in this per like the same heuristic, it will sort of come to this equilibrium where all of the peers are predicting the same number of frames for each other. So if the slowest peer, in this case, is predicting 4 frames, after we sort of go through this cycle of calculating the advantage and skipping frames, all of the connections would end up with like approximately the same number of frames of prediction. And of course, like connections don't stay the same. There'll suddenly be like a spike in lag and then things will change, but the system's kind of always checking and always recalculating, so that basically you're always going to be predicting the number of frames necessary to keep everyone predicting the same number of frames as the slowest peer. I hope that makes sense. That was like a really terrible explanation. Like, I'm wandering all over the place. I should make like a blog post or a YouTube video describing this in detail when I've had a chance to like really sit and think through it, of how to explain it. But I got it from that Kamasutra article. It's a brilliant way of doing it. I think GGPO is doing the same thing. But that way, the bad side of it is that the game is going to get more and more artifacty to match the worst peer. So you could have like a 4-player game where 3 players have a really great ping and 1 has a really terrible ping. Well, now everyone's going to be seeing like loads of artifacts in order to, match with that crappiest peer, which sucks. That's just a thing with rollback and prediction. It's not great when you have a lot of players because of that fact that you're always sort of going to the lowest common denominator, but it will be the most fair. It will not allow one player to have fewer frames of prediction and hence have more information on which to act, and the other players having less information. Anyway, be interesting if a peer-to-peer connection could project a virtual server to split latency among clients. Nionel guessed Kamasutra before my brain came to it. Saying, what if it's possible to virtually project a server in internet space? I'm not sure. Hey, Mr. Oswald, man. I'm not sure. Not sure what you mean by virtually project a server in internet space. I'm very curious if you could explain more what you have in mind for that. Anyway, so thanks for the awesome questions. I can't remember what I was talking about before we started jamming about that stuff. No, I actually said Kamasutra after I found it. In any case, we both came to the answer, and I can't remember the name of the game too, but it's a really great article. I want to find this article and share it with you guys, because it is basically the blueprint on which I built the rollback netcode in my game. It was kind of like, here we go, in Versus. This is the article. I'm going to put it in chat. This article, combined with actually reading through the C source code for GGPO, is the basis of the rollback netcode in my game and the asset that will eventually appear on the Godot asset library. Let me just... Here we go. Wait, did they change the way... No, this isn't Kamasutra. This is like on some other thing. I was about to say, did they change the theme for Kamasutra? Where's my green? Where's my green blobby 90s style web page there? Project a virtual server between peers. I'm just not sure I understand what you mean, Gauntlet, about projecting a virtual server between peers. So peer-to-peer, where, everyone is connecting to each other, are you sort of like saying, can we imagine what the server would be if it existed between those peers? And I mean, also too, like in this game, we're using stun and turn to figure out our peer-to-peer connections. Oh, Mr. Oswald, man, got a cool-looking character. I like it. It's like some sort of fisherman with a cool hat and a braid. But anyway, if there's no way for the peer-to-peer connections to be made, it will actually connect to a server in between the two peers to relay the traffic. Which relates to like this totally unrelated thing that I am obsessed with the past like 2 days. Okay, so I started writing a stun client in GDScript last night, and like I know I shouldn't have been working on this. I should have been working on Retro Tank Party for the stream because that's what we're going to be working on during the stream. But I just couldn't stop thinking about this stun client, which of course we don't need for Retro Tank Party right now. It's using stun via WebRTC. So we are using stun, but we don't need to have like a custom stun client. But in Godot 4, it's possible to create peer-to-peer mesh networks with eNet. And so you would need some way to do the NAT hole punching to allow those different clients to connect to each other via UDP. And one way to do that is via stun. And since we don't have WebRTC to rely on, we'd have to have our own stun client, which is what I started implementing yesterday. And man, if you folks are interested in this, I would love to just keep working on this stun client because like my brain can't stop thinking about it. But it's like really low level stuff. Like I had to read the RFCs to figure out how it worked, and then like I was sending data to my stun server, which is based on Coturn, which is an open source stun server, and like kind of looking at what I get back and figuring it out. And I was actually like working on this like all the way up until the stream started because I'm just so obsessed with it. So if other people are interested in it, maybe we can hack on the stun server a little bit, or stun clients, that is. But the thing I was planning originally to do this stream on was these debugging tools that I've started making for Retro Tank Party. So let me show you what they look like. I added this new mode to the game, which will build what I'm calling detailed logs. How do I open this? And then we can open those detailed logs from all of the clients. It'll take like a log from, every client, and then put them together and allow us to kind of like explore it. Why does it keep opening this? Aren't I on Log Inspector, TSCN, open you. Okay, there we go. So here's our Log Inspector. I have some logs from previous times I was running it. I need to make a nice like progress dialog. I started it but like didn't finish it. I'd actually have to use threads to make the progress dialog work. Anyway, so it loaded up the logs from 2 different clients. I guess peer 1 and 2. It got 2,282 ticks of data that contained 6 state or input mismatches. And then you can see here, like here's the input on tick 1. Here is the state on tick 1, and I can sort of like walk forward through these ticks to see the different input and state that happened during the game. And I can jump to the next mismatch, and it will actually show me what mismatched in the state between the peers. So here it is showing that on this tick, peer number 2 had some differences. So on peer number 1, we had this value for the fixed X position of green twigs 3, and this other Y position for the same thing. And we can go look at all of the different mismatches and see specifically what mismatched. And I don't know what the heck is going on with these green twigs, all these state mismatches related to green twigs. That's something that I will need to look into at some point. But the more interesting thing here is the thing that I'm hoping to build today, that I'm hoping to build on stream. This is looking at the state and the input. There's another mode that I want to add to this that looks at frame data. And what I am imagining here is that we'll be able to see like some kind of visualization of all of the frames, and we'll be able to inspect and say, okay, on this frame, this client did 2 rollbacks and this client did 4 rollbacks. And on this frame, here are all of the timings. Like when we were working on all that performance stuff, I had to do all this like janky logging to the terminal. Instead, we'll log here and we'll be able to see, different performance timings. And most importantly, we'll be able to see the flow of data between the different peers. Because the last big remaining problem in the game is we are fighting this flow control thing with WebRTC, where if there's like any kind of packet loss, WebRTC will start like holding back messages, and it's breaking our whole sync process. And I have spent, I don't know, just a bajillion hours trying to come up with ways to work around it. And I've found a bunch of little techniques that seem to improve it. And the more that I was working on it, I just kept thinking in my head, like, I just don't understand what's happening well enough. Like, if I could just see it, if I could just see with my eyes, like that this peer is sending this message, and dunk, 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 this many frames later, it's being received by this peer. And being able to actually visualize that, I think would make it possible to really understand what in the heck is going on to like actually fix it. And I think this tool in general will be really helpful for the asset, for the Godot asset library, for other people who make their rollback-based game and want to, debug problems. And we're running it here by running the scene, but the way that I actually expect people who are using it in the real world to run it would be as an editor plugin, which I have it, if you go under Project Tools Log Inspector, it will open up a basically the exact same thing, but within the editor. And the reason that I'm not doing that we're not going to be opening it in the editor this way when we're hacking on it, because there's just like weird stuff that happens when you're hacking on an editor plugin and then also running that editor plugin. It's much easier to like run this as a scene while you're actively developing on it. Like editor plugins can crash the editor if you do funny things, and so I'm just not going to mess with that. That's why we're loading it up over here. But I think when people download this asset, they'll go to project settings and plugins, and it'll enable the Rollback netcode manager, and that will, inject this thing over here in tools, which will let them open it and inspect logs in this kind of way. And for sure, I'll need to have a working progress dialog. Some people are just sitting here like, why is it hanging forever? But yeah. So let me see what was going on in chat. And then we'll dive in. We'll actually start working on it. Hey, Aircy, thanks for coming. It seems like Kamasutra rebranded to game developer. Wait, did it? Unless like I thought maybe I was on a different website, like it had gotten published somewhere else. Let's go to Kamasutra. Seriously? When did this happen? Kamasutra! It's the end of an era. Kamasutra is now game developer. I missed the giant message up at the top. Wow. I mean, this looks way more professional. Kamasutra was a funny name that probably made people not want to go there. Someone says Kamasutra out loud, they're going to think it's not safe for work. But man, I miss you, Kamasutra. Come back. Wow. Okay. I'd love to go fishing. I need a boat, though. I'm not sure what conversation that was in reference to, but Mr. Oswald Man likes to go fishing. Now, speaking of web dev, I have a very strange feeling that the 90s or 2000s style websites will reappear as a hipster trend. Maybe. Gauntlet, they have a Git add-on for Godot, but it only makes commits and no rollback partially implemented. Wish they had a fully implemented add-on for Godot. And is there like stuff going on in one of the chats that isn't making its way to Discord? I feel like I'm missing some part of the conversation. Well, anyway. Yeah, the Git add-on for Godot, I'm not a big fan of either. Ooh, Aircy, you got a cool. You're like a kung fu orc. Like that looks awesome. But yeah, I'm also not a big fan of the Git add-on for Godot. I feel like it just all Git graphical things, like they kind of hide how Git really works, and I always get so confused. And anyway, let's start building something, guys. A half hour in, we haven't done anything. Let's get down to it. So here is our log inspector thing. What I want to do is have the this thing up here where it says state input. You switch that to frame mode. It'll load up a new scene that we are going to create. I did some like paper notes about kind of how I'm envisioning this working. I don't know once we get into it if it will actually make sense. But I'm kind of picturing, here, I'll draw it in here. I won't hold up my notebook to the camera. That's not good streaming etiquette, is it? I'm kind of picturing like we'll have like these long rectangles for each pier. That will have, I don't know, some sort of cool thing going on in them that represents the activity on each frame. And then we will pick a frame and it will give us some info down at the bottom about that frame on every pier. So we'll be able to see, we'll be able to pick one spot in time. I guess, I don't know, should it be about time or should it be about frames? I think maybe about time. So along the bottom we'll have time. And we're going to try to like line up the two graphs based on time. And so that when I pick a frame here on pier 1, it'll jump to the equivalent frame on pier 2 based on time, and then like show me down here some data about what's happening. So it would be like, what kind of data do we want to know? We want to know like, let's say rollbacks, and we'll have pier 1, pier 2, and like kind of like a grid, maybe, I'm thinking. So then we'll have like rollbacks, like we did 2 rollbacks, so we did 3 rollbacks. I'm not sure. We're gonna discover this together and kind of figure out how we want it to work. All right, so we have this VBox container, this HBox container. Okay, so this is the actual like control. That is the state input view. We need to add a sibling of that. So we'll, I guess, hide that one. I'm thinking it's still going to be a VBox. So we'll add, or actually, let's start making this in its own scene like straight away. We'll call this scene maybe frame viewer, something like that. And it's going to have, or actually no, let's actually make this be a VBox container. And we are going to want to put, I guess, a variable number of piers, and then also sort of like a data grid area. We'll add a control for like the data grid. I'm just going to put something to be in there, which we will change completely once we kind of figure out what we're doing. And, oh, similar to the log inspector, or not log inspector, similar to the state input view, we're going to need like kind of like a tick control at the top, but instead it's going to be frames. So we'll just actually steal that from the other scene. We'll do merge from scene. This guy. All right. That's going to go below the data grid. And we need to change it up. We don't need a previous and next mismatch button, although we probably will want to have some sort of jump button in there. I just don't entirely know what it's going to be yet. We'll say frame number label. Although, I wonder... So we want to deal with things in terms of time, because that's the most useful for network traffic, right? Because we want to know, I sent these messages, you know, at this point, how long did they take to arrive on the other pier? that's where time makes the most sense. But then also ticks do kind of make sense too. If I want to say like, well, here's what I was doing on tick 27. What was the other peer doing on tick 27? So maybe we do need a thing with ticks and with frames. Wonder if I should... Although, maybe we're just going to end up needing like more modes. I don't know. Let's just stick with the frame thing for now as we're figuring out what in the heck we're doing. Save this. They're here. And the most interesting part of this is going to be how are we going to like do that visualization? Or does it make sense to try and do it without the visualization first and then add the visualization after? That actually does make a lot of sense. So what kind of data do you want to keep? Actually, let me show you guys in the code what this actually looks like as far as how we're gathering the data. Like in Sync Manager, it's basically just set up so we can store any kind of data we can think of. We'll go into physics, process. So basically, anytime we want to track something, we do this if logger, stash some data, or we have a couple of methods like start timing. We're timing how long the rollbacks took. And yeah, here's stop timing. We're going to record how long that took. And basically any data that we can think of, like in here, we're recording the rollback ticks. So I'm sure it's not recording as much data as we actually want. But let's just pick a piece of data that we care about and let's get it visualized somehow. Or even just displayed, just as a first step. Yeah, here's where we're skipping ticks due to that advantage calculation I was talking about earlier. And it would be good to know, like, if we're skipping a tick, we should record that we're skipping a tick. Osman Pro HD, welcome. Thanks for coming. It's been a while since you've been on stream, and it's been a while since I've been streaming. Thanks everyone for coming. Is Wednesday a better day, or are you guys just here because you missed me? Like this is a lot more people than usually come to my streams, or at least have come to my streams lately. Osman Pro HD says he is still the same with his not so good internet. My internet isn't great either. All right, so what was I doing? Okay, we are going to load up the data. We know that we have, oh, we are recording that ticks are skipped. Cool. So let's just try to visualize rollbacks, like number of rollbacks that happen on each frame. We'll start there. So Arbering says both. I'm assuming you're saying it's both Wednesday is a better day for you and that you missed my streams. All right, so we have the log data kind of segregated into this other log data class with some very unfortunately named classes. Let's not call this state frame. That's going to get very confusing. We'll call it state data, input data. And it's going to get confusing because we need to call something frame, right? We need to call something frame data. And if we're also calling something state frame, that's just going to be weird. Data, frame, data. All right, so we need a class to store our frame data. Wait, did I just change that to be called frame data? I just heard myself say frame data out loud. No, state data, input data. Okay. This we're going to call frame data. And similar to these, we're going to have some sort of identifier, but instead of tick, we're going to call it frame. We're going to have to figure out exactly how we're going to increment that. That's going to be interesting. Data, dictionary. Let's just start with that. Add a little constructor here to stash the data on. Normal boilerplate stuff. And we need to read it. We'll use that dictionary to hold the frame data. Oh, this is going to need to be different though. So the frame data is different than the state and input data in that there isn't inherently like a thing. So the state and input are all attached to a tick, which has a very, very specific meaning and an identifier to go along with it, whereas the frame data is a little bit wacky. The reason it's wacky is we have things that happen during the physics process, which we are calling, what are we calling that? We are calling that the tick. There are things that happen during the process, which we're calling the interpolation frame. It's basically the way that we have things working is the tick stuff happens during physics process, and then during process, if we haven't done physics process, we will do the interpolation and then some other stuff that we kind of just want to separate from the tick for performance reasons. And then, because Godot can have like signals fire and RPCs come in that aren't during either of those two things, they're things that happen between the frames, we have interframe events. So there isn't like a natural like identifier for what is happening here. We'll have to come up with some kind of scheme where we're saying like, okay, so a tick happened, we're going to count that as a frame. Some interframe stuff happened. Is that like another frame, or is that part of the same frame? Right? Like it's going to get kind of confusing how to refer to it, and hopefully something will start to make sense as we're working on it. What's going on in chat? Studying time zones are the reason I could join the stream. Oh, cool. Arburing confirmed my assumption. And Osman Pro HD, how does rollback work? So many script files that make me dizzy. Like, in general, how does rollback work? I mean, I have some old drawings that we did on earlier streams where we were talking about the process of rollback. I think, yeah, this is my classic, how does rollback work in a game? And I don't really want to dig back into this right now to like totally derail things, but the short version is, you know, when you receive data from the other peer for an older frame, you roll back to that frame, you inject that data, that input, and then you roll back forward, which can lead to some artifacts of things suddenly jumping position where you would expect them to sort of gradually move there. But if the jumps are small enough, and we have interpolation to smooth them out a little bit, then they're hopefully not noticeable, although definitely at like high latencies, the artifacts of rollback and prediction do become noticeable. Anyway, that's kind of the high level version of that. Yeah, we have, there are a lot of script files. And I hope Ricardo is right that this is in architecture. I try to split things up so that each thing has a small single purpose, although some of my scripts have gotten a little bit crazy. Like the sync manager is getting really big. And maybe like I could break up some of the individual classes that exist in here into like separate files to make the script smaller. But there's just like a lot of stuff that the sync manager needs to do to make rollback work. And some of the things that aren't like core have been split out, like all of the spawning stuff is split to a separate object. The sound stuff is split to a separate object. But man, this it might be generous to call what's going on in this file in architecture. Anyway, so does it make sense for frames to be an array or to be a dictionary? Unlike input and state, it may actually be better for frames to be an array. Input and state, like the dictionary thing, makes sense because they have an identifier. There's a possibility we're going to be missing some of the frames, which I guess could happen here too. Maybe for consistency, we'll make it a dictionary. I'm not sure that's the right choice, though. This will be frames. Input state frames. Max tick. I guess we'll want to track a max frame as well. Max frame. To go with our max ticks. All right, and when we are loading the logs, we now need to not just add input and state data, we need to add some frame data. I just realized these variables still are named this way. I'm gonna place those. Input data. Input data. I'll do the search and replace. This is getting too tedious. Replace. Do the same for state frame, state data. All right. Say if not frame data. We have a sort of problem here too. Because there is no natural number, we're gonna have to count the numbers too. We're gonna need a frame counter, which this is definitely gonna have to be a dictionary. We're gonna have to keep a count of the current frame for each peer. So when we start loading log data, we'll get a header telling us what the peer is. And we will need to start a frame counter here. And we only want to do it if we don't already have this peer. Do we do something to explode if we already have a peer? We do. Okay, so we should be able to make the assumption that we don't. Okay, that's awesome. That's less code for me to write. Okay, we need to start a peer counter for this peer, or frame counter for this peer. Then down here, we need to get a new frame number, which is going to be frame counter for the peer ID. Hang on. We will increment it, and then we will get it. Catch you later, Osman Pro HD. So, all right. Do our frame counter stuff here. We're going to generate just a integer. And then we need to grab it if it already exists. Data. We'll create a new object with our frame number. And I think we use the data itself. So these detailed logs, they're just like big collections of JSON. I can show you guys one real quick. I have to make my way to where Godot stashes the user files. Here, I'll make this huge. And we've got this detailed logs directory that it's making, and it's putting all the logs in here. We just look at one of them. I guess we'll look at it in Vim, because why not? Every line is a JSON object, which represents a single entry in the log. And these log type 0, I think, are the interframes. And what else do we got? Log type 1. Or hang on, log type 0 might just be unknown. And log type 1, this looks like frame data. Log type, let's get to some other log types here. Log type 2, this looks like state data. This is state data. Anyway, that's just what we're dealing with. And I think the log type 1, it's just taking the whole JSON object is kind of the data. That's what it is. I guess we don't need to keep the log type in there. But okay, let's go look at frame data, the frame data class that we made. And we're just taking frame and data. I guess we should also take like the type. So we'll say type, which is also an int. It's from that enum. So frame type data. So frame data. Number. Entry, this is frame type, and then the log entry data itself. Does that look right? Okay. Now we need to add that to our frames list. And if it does exist, oh, hang on. This is the data for a single peer. We need to keep all the peers together somehow? Does that mean separate collections of frames? I think it does. I think this frames dictionary is going to get a separate set of frames for each peer. Okay, so then how does that look? So then we're going to need to do something like var peer frames equals frames the peer ID. And we'll need to make sure that we create this here. So frames header peer ID. Let's just store the peer ID. Address a dictionary 3 times in a row probably needs a local variable. Peer ID, peer ID. Okay. And maybe let's just use an array. Rather than the dictionary thing we were doing before. I'm switching back. I was like, we'll make it be a dictionary, not an array, because the others are dictionaries. But let's come back from that and see what it looks like. So frame number, peer frames. That also means we don't want to increment before. We want to increment after, because we're going to start with 0. The first index in an array is always 0. So frame number, get our peer frames. We don't have to do this has check, because we're just going to put them on there. Let's make the screen bigger. And then peer frames append, or maybe we don't even need that now that we've reduced the amount of code here. Yeah, this could probably just be frames ready. So we're only accessing it once. All right, that's actually really simple. So that's going to bring the frame data from the log file into here. We'll be able to access it this way. Max frame. How do we calculate max tick? Where is max tick calculated? Because we need to calculate it the same. Oh, here we go. Interestingly, though, we don't want to do this here. I don't know. Let's leave that way. I think that's okay-ish. And then we want to update our max frame. So max frame will equal whichever is bigger between max frame and the frame number. And max, I'm pretty sure, returns a float. We do not want a float. So we'll make that, cast that to an int. Okay, let's get through this boilerplate. So we are loading the data. Our frame viewer, let's get back out of distraction-free mode here. We're going to drop some stuff into our data grid. We just want to hold something in our data grid. How are we going to do this grid? Like, I'd like to do it the way that I drew here. What's the best way to implement that? So as a grid control, we would need to... Grid control just sounds hard to manage. Is there like a table-ish control in Godot? So docs table? Oh, interesting. There's BB code table stuff. Maybe we could do something in BB code. That would be easier to manage. I mean, we could code up anything, right? Like, I just want to be lazy right now. What is the laziest thing we could put together now so that it works at all, and then we can start trying to make it better? Because like the thing I really want to do is the visualization thing I was talking about anyway. So I don't want to spend too much time on making this table. A tree, Ricardo says. Yeah, a tree could maybe work-ish. I don't know. I'm thinking about maybe doing a BB code table thing. Okay, do BB code tables work like HTML tables? I don't see a row. I just see cell. Oh, okay, so the number of columns, we just give it. Yeah, let's do a BB code thing. It's simple, allows us to move forward really fast. So this data grid, we are just going to replace with a rich text label. And it's in the wrong thing. Okay, this is going to be data grid. And we want to use the sizing flags to tell that to take up the whole area. Bam. And that should be good. This will allow us to just sort of step forward in the frames, get some data printed out. So let's start on the script here. Frame viewer script. Because this is eventually going to run in the editor, we have to make everything be tool script. Let's grab all the different nodes from the tree. Need our frame number. What did we call it in the other one? Called it tick number something. Tick number field. Going for consistency here. Tick number field. Frame number field. And our data grid. And we need, like the input viewer thing, we need to keep a couple of things here. We need a reference to the log data object. We need a way to set it. Oh, yep, we need to actually load the log data script. And we need to do some stuff when we refresh the data. I guess the same stuff actually exactly here, just with frame numbers instead of tick numbers. Max frame. And we will create this method in a moment. This on frame number value change. That's the method connected to the value changed signal on this tick number field thing, frame number field. So let's go make that method. Oh, I'm on the label. Here we go. There we go. Value changed. And this is where we will actually like throw the data into the data grid. So say like var, I don't know, BB code. And we want to have a column for the peer ID and then a column for each of the peers. So the BB code will be, let's go look over here. It will be table equals number of columns. So table equals, we'll inject that, which is the log data peers size plus 1. And in the end, we want to close this table tag. And we're going to set it on the data grid. Our burring is sharing a link. Maybe because yeah, you know, I haven't done much. I haven't done anything with trees. I always just assumed tree was the same as like the scene tree control over here on the left in the editor. Let's take a little tangent. And check out tree. I was kind of hoping it would give me a picture. Tree shows a tree of items that can be selected, expanded, collapsed. Tree can have multiple columns. Multiple columns! Okay. Yeah. Ricardo, I think you're right. I think a tree is the thing to do if we can have multiple columns. We don't really need to use sub-items. Or maybe we could. We could have sub-items that are like, we could have a timing row, and then expand it, and then would have like sub-items for each of the timings. I'm kind of curious now. Like, I just want to throw a tree control into a scene and see what it looks like. Looks like nothing. Okay, multiple columns. Is there a way to make items in the editor? Or maybe we have to do them in code, which is fine. I don't want to go down this tangent anyway. I mean, I do want to go down this tangent. I want to go down all tangents, but I probably shouldn't. Yeah, it's like row selection. Anyway, that's cool. That's cool. Definitely for the next version, for the as we improve this thing. So okay, our frame viewer here. Let's get back into the code. What are you yelling at me? Oh, it's an operator precedence thing. All right, so we are going to, or actually the first column is always going to be empty, or the first cell. Let's get back to BB code here. So just cell. Okay, we'll put an empty cell. Then the following cells are the peers. So we'll do for peer ID in log data peer IDs. add a cell for each. And then we'll be putting the different pieces of data that we care about, which let's start with just like frame type. The first piece of data will be frame type. And it would be nice to have like a sort of extensible way to add things in here without having to custom code each of them. So that will be probably what we do after we add the first one or two of these. But we'll start with cell frame type. And then we need to loop over the peer IDs. And we need to grab the frame type from the frames for that particular peer ID. So we'll need to do what is the best way to do this? So underneath, that's frames peer ID, and then data, and then frame type. But we probably don't want to write that exact line of code, because what if there is no peer in the frames here? What if there is no frame type in the data? So we probably want a helper method on the log data, which will be something like get frame data. We want to give a peer ID and a frame number, which will give us frame data or null. So we'll say if frames has or not has. We're gonna do all the negative cases first. If frames does not have peer ID, then we return null. If frames peer ID size, if frame number is greater than or equal to size, then we return null. And if all those pass, then we return frames peer ID frame number. And then I guess we don't need anything special on frame data, because we can do frame data.data.get for if we're worried that a particular key does not exist. So although it would be kind of nice to have a higher level abstraction here to deal with if the frame data frame itself is null. Here, we'll say get frame, and then we'll do this one is get frame data, where we take peer ID int frame number, key, which is a string, and then a default value, which is anything, and we will return anything. So I guess I'm not going to put a return type there. We'll say var frame equals get frame peer ID frame number, and then we're going to say if frame, then we will return frame data get key default value, else return default value. And I guess probably we want to give a default value of null. And I guess we don't even need this else there. There we go. That's nice. That will make for a nice experience here. Log data get frame data peer ID. Oh, the frame number. How are we tracking that in this one? We just plain aren't. We're using the controls data. So okay. We will want to do frame number int value. Probably write that a little more tersely. Oh, not that I want people to leave my stream. My computer just informed me that there is a Future of Godot live interview occurring right now with Juan and Remy on Redefined Game Dev. I'm definitely going to be watching that later. Don't go watch it now. Stay on my stream or go watch it now. I mean, I want you to be here. I want company, but like, certainly don't feel an obligation to stay if that sounds really exciting to you. Okay, frame number, and we are getting frame type, and I guess we need the enums of frame type, which is in logger. And what is a good default frame type? I don't know, interframe, I guess. Okay, so that's a lot of code that we just wrote to get to this point. Let's try and tie this all together and see it working. That is ideally what is going to happen next. We want to add our frame viewer. Not there. I want to add it below. And why don't I see it? Oh, so something that's really annoying. So this log inspector is a dialog, right? Dialogues, you can save them as visible, but as soon as they're instantiated into a scene, they will set themselves as invisible until you like call the one of the methods to pop them open. But because this is a tool script, right? Because we want this to run in the editor, and it has tool at the top, that means it keeps loading in the editor, which means in the editor, it keeps setting it to invisible, and it just is driving me crazy. Like I keep having to unhide it. Anyway, so the frame viewer here, we need to mess with its size flags a little bit to make it expand to fill the bottom. Oh, and let's go make sure that our data grid is configured for BB code. And let's put some default text in there just so, I don't know, we can see it. And all right, so let's run our log inspector. We'll load up some data. And it crashed, or it didn't crash. It's yelling at us because it can't save. Oh, okay, so over on this script, we were using the old names of input frame and state frame. Let's close this. Don't save. So it won't yell at me about being unable to save that. Okay. Okay, so yeah, I guess we still have to make that control actually work. That will be next. Let's just load some data and see what happens here. Some data loaded and does not appear to have worked. Okay, so we loaded a log, we got some ticks. Let's explore here and see if we can tell what happened. A log inspector has this log data object, which has some constants, but it doesn't have. Oh, okay, we've missed a couple of steps. We missed a couple of steps as far as integrating. So we need to on ready var, we need to grab the frame viewer control We need to pass it our log data object so it knows where to get the data from. And we need to occasionally tell it that the data has refreshed. There's one other spot we need to do it, I think. Here. All right, let's try this again. Let's load some data. Hey! And we can go through and get these different frame types. This also occurs to me that I should have those as text and not just as numbers. And here we go. Now we have two. Is this going to actually be useful like this? Because we're looking at frame numbers, which are just going to be totally different between Pier 1 and Pier 2. Yeah, this might not actually be doing exactly what we want, but I think it's okay for now as we kind of advance things forward piece by piece. But it's working. We got things coming in. What we did is working. What we did isn't maybe what we want, but what we did is working. I do want to turn these into some text so it's easier to understand what the heck is going on here. So we'll say like frame type equals this whole thing. Then we're going to convert it to a string. And we'll just do, I don't know, something simple to do that. There's probably we'll make a dictionary. A dictionary will help us convert this. We'll even make it be a const dictionary. So be frame type names. And we'll do logger frame type interframe frame type. What's the next one? Tick logger frame type interpolation frame. Oops. Interpolation frame. Okay. That's maybe a little bit more verbose than it needs to be, but all right, let's load 2 logs at once, which is what we would normally probably do. We'd have a pack of logs from all of the different players in a particular match. We'd open them. Ooh, we have hit an error here. Oh, interesting. You could also use that enum in GDScript behaves like a dictionary, but it doesn't contain strings. So it does behave like a, or you're saying I could also make that be a num? Yeah, I guess I could also make that be an enum. Or no, I couldn't, because enums are always integers, right? Or are they not? Can GDScript let us make enums that contain non-integers? Let me just try that. Enum, test enum. And then these, of course, are integers, but their values, hang on. No, so these are names. With a num, we give it a name, which acts as a dictionary, which actually doesn't work for us. We need to have integers to strings. Call keys on the num. You can call keys on the enum. So can call keys on the enum. Could I invert it? Because what I would want to do is I would want to swap the keys and values. If we can do that, that'd be super clever. Let's go Godot dictionary. Is there a quick way to swap the keys and values? We could make a little method that does it, and just try it. So let's do like static func reverse dictionary. Then we'll loop over the normal dictionary. We'll say R K equals K. Or it's not really reverse, is it? It's like flip. And then we would say, can I define a constant using a static function? That'd be so cool. Say like const frame type names to dictionary, and then we would do logger the original enumeration, so it'd be frame type. Okay, apparently a static method is not a constant expression, but we could still make and I guess we would do that on ready. So we'd say frame type names equals flip dictionary of the original enumeration type. Okay, so theoretically, that should be equivalent to this one that I made custom up here. And so I would do like frame type names, frame type. Let's see what that does. There was also an issue. We came here originally because the debugger came up. Apparently there was a frame type of 0, which doesn't exist, isn't a valid option. So we'll say like if frame type equals 0, we're going to set it to okay. Let me figure out how to handle that. Maybe I guess I do need to do this slightly more verbose. Frame type string equals this if frame type names has frame type, or no, I can just do get. Yeah. Okay. Get. Otherwise, we'll put in unknown frame type string. Let's try that. Let's see if that works. It's kind of saying, I mean, if you have a num type a equals 0, b equals 1, then you can do type keys and get a and b as strings. Right. Which everything's coming back unknown. Okay, let's just check if this thing is flipping correctly. Because really what we need is just the dictionary backwards. See what we get. Okay, yeah, this actually looks right. So 0 interframe, 1 tick. Now why is that not actually finding the value? Is it a type thing? Frame type name. So why isn't it? Wait, and 0 was coming up as nothing? Why isn't this working? Is frame type like inadvertently a string or something like that? Let's... When you're trying to look up something in a dictionary and you have like the number 0, it is different than the string 0, and that has hit me before. I'm doing Godot-ish stuff. Okay, so frame type 0. And we know that frame... Wait, what? Frame type string. Is it because it doesn't have a value yet? It's giving that? Okay, there we go. So join to unknown. So frame type, is this the number 0? Is this the number 0? Is this the string 0? And then if I go look at frame type names, this all looks right. Like this looks like this should work. It looks like 0 should lead to... Okay, here's what we're gonna do. I'm gonna wrap this in int just to make extra sure that that is the integer and not the number. Hey! Okay, so for some reason we're getting the integer. Now this appears to be working. Cool. All right. So we are loading the data. We're displaying the data. We need to have the thing that lets us swap back and forth between the two modes. Then we can commit this, and then we can get down to like the interesting part. And I can kill this thing. I'm just cleaning up the code we just wrote, making it less verbose, more direct. And that should be good. And what we want to do is have the changing the mode thing. And that would be in our log inspector script. Please take me there. All right. And actually, hang on, we need to bind to this input changing. So item selected. And what values did we give these? Oh, data mode. Okay, we have an enum for it, so this should be good. So if index equal, or is it index? Or we want the value of the thing? Okay, first let's just print out this index. And see what happens. Index 1 for frame. Index 0 for state input. Does that match this? It matches. Okay, cool. So index is poorly named. It is the value that we gave it. So let's start by doing state input viewer visible equals false. frame viewer visible equals false. We'll say if index equals data mode, state input viewer visible equals true. If index equals data mode, frame viewer visible equals true. Do it. Go. Okay. Okay, cool. And we need to, I guess, start out on the one that we're shown as starting out on. So I'll change this up here to be 1. Okay, we have the beginning of the 2 modes here. Let's make sure that they're both working still. Since I haven't taken a look at the input state mode since we added this one. So here I can go through frames, input state, I can go through ticks. All right, okay. That's a thing. Let's save this. We'll commit it, and then I want to start trying to see a better way to visualize this, because this is just wrong so far. The way that it's showing the data is not really useful at all, because it's lining it up based on frame numbers, and we actually need to line it up based on time in order to do anything useful. And so we might need to change that control entirely. Hang on, let me commit this and then I'll start thinking. If I try to think and commit at the same time, it's just not going to happen. Okay, so started adding frame mode to log inspector. So we'll push that. That'll kick off some builds. And yeah, Ricardo, your thing worked. We did eventually get it working. So I'm happy about that. It is pretty clever that we can have this little method that will turn a num dictionary into a give us the name of the thing dictionary. Oh, hey. What? Guys, have you ever noticed this button before? This items button here? Is that new, or have I just somehow not known it existed? What the heck? So here, look at this. I was adding these in code. But apparently you can add them in the editor. Am I just an idiot for never having noticed that? Or is that like always, and has it always been a thing, or is it a new thing? Hang on. When we were looking at the tree control earlier, was there a thing that we could have used for that too? No, there's no items thing up here, just the layout and anchor stuff. When the heck did that items button happen? That is awesome, though. Where's the thing? Give me the thing. I want to see it. Mode. I can come here. I can add an item. Jeez. That's really cool. Okay. Learn something new and awesome every day. Okay, so we where are we at here? We want to try and line up the data based on time. And so maybe this frame counter is just like the wrong control. Maybe what we really need is a time thing. And I'm not entirely sure how are we going to conceptualize that. because obviously frames won't happen at exactly the same time, right? Maybe it will be whatever frame happened just after the time that would be in some kind of time control. Do we have a time control? Or we'll just have to make it up with a text edit thing? I think we will. I think we'll just have to make it up with a text edit thing, and then we'll have to add some buttons that let us skip forward and backward easily. Because yeah, so what would be the most useful thing to have here? Okay, and we're also going to need to translate the time into something that works across all of the different peers. So Ricardo says, I saw the item editor before, but it took me a long time too. Yeah. Okay, so we're getting time stamps for each of the frames from each of the peers. We're just going to make the assumption that the time is close enough on each peer. It's UTC time that it's giving us, but clocks can be wrong and whatever. But we're just going to ignore that for now. With my testing, where I'm running it on the same computer, the clocks will be totally synchronized. But we'll need to make these times be relative to the match start, so that we can deal with them in kind of a sane way. Figuring out when the match start is something else that we're gonna have to do on our log data class. Same way it's figuring out like what the max ticks and the max frames are. We are going to need to figure out a match start timestamp, or we'll say start timestamp. So then we can transform the... And will we transform it here, or should we transform it elsewhere? I think we should transform it elsewhere. We'll keep this data pure. We'll do that translation somewhere else. And then we will figure out our start timestamp similar to how we figured out the max frame, but instead of max, we're going to use min, which means we can't have this start timestamp be a small value. Or we make a special condition for 0. That's another way to do it. So it would say start timestamp equals the minimum between start timestamp and log entry. Oh, of course we have to know if it has a start time. Blah. Okay, so if hang on, what do all entries have? Most have a start time and end time. This one is weird and has nothing. It should probably just be skipped. I don't know what the interframes have. Do we have any other interframes? Okay, well let's just make the assumption that they all have a start time. And if we don't, we just won't even count them. If log entry has start time. then we'll make it be the minimum of start time and log entry start time if start. Actually, I'm just gonna call this start time instead of start timestamp. Start time is greater than 0, else log entry start time. What did I do wrong here? Oh, missing one paren. Okay, so this is going to figure out what the lowest timestamp is in any of the logs. And I guess we need to remember to clear that when we're clearing stuff. So that will let us count in milliseconds. I think those are are those seconds? What are we counting? It actually would make the most sense if they were microseconds. Let me go see what we're actually counting. Let's go to sync manager here. Search for start time. Okay, they are microseconds, which is good. Microseconds are good. We get a lot of granularity there. There's potentially a lot of inaccuracy. Or wait, no, were those timings I was looking at? Okay, no. It was microseconds. I was right the first time, I think. Yeah. Wait, hang on. Start time isn't what we want. Because start time is relative to when the engine, or get ticks microseconds is relative to when the engine started. But we need to know like real world time. I thought that's what we were recording. I guess we aren't. I'll have to fix that. What do we got? To ticks start time, remote ticks received, end time. Hang on, let's go look at the logger. Okay. This is recording its own start time and end time. Oh, and okay, so this is system milliseconds, and the duration is recorded in microseconds, which is converted to a floating point milliseconds. Okay, so start time and end time are system time milliseconds, which milliseconds is probably fine for frame start and end times. For these durations, though, having sub-millisecond accuracy is nice. So, okay. I've now established what it is actually doing. Let's go do something with that. I was working in log data. And okay, so we're getting the start time. That is good. Even though it's like real world time, we are going to display it to the user as relative millisecond time. And let's take that over to our frame viewer. And we're going to just get rid of this frame number thing. This frame number thing is not helpful. It's not letting us do what we need to do. So let's, I guess I'll convert this to be time. A time label. And then this, I guess could still be a spin box, but it's going to have like, it's going to get really big. Say time And min value actually is going to need to be 0 in this case. Max value we'll need to adjust. Okay, so yeah, we'll need to also keep track of the latest end time also. So let's go back to log data. All this data crunching. I mean, Godot is actually a pretty good engine to do this kind of data crunching stuff, especially once we get to the point where we're going to visualize it for real. But this is certainly not what I'm doing every day in Godot. That is the truth. Okay, so here we need to do a very similar thing, except we don't need this ternary because we're now dealing with a max value. Okay, so this should allow us to set up the value range for that time label thing. And we will attempt to use that. So when we refresh log data, oh, we have to change all this stuff too. So this is time field. This would be, oh, and the max value needs to be the log data end time minus the log data start time. This is not frame number anymore, this is time field. Time value changed. And we gotta change this. Connect it to the new signal. Okay, so this is going to get a little more complicated here. How are we going to get a particular frame for a particular peer based on a time? So I guess that'll take us back to log data. We'll create a nice helper thingamabob. We'll add a new get frame by time, peer ID int, and then we'll say and we're going to want to take the time as absolute values rather than relative values from this perspective. So we'll need to do some of the same things as here. If we have a lot of frames, this could get very slow. I don't know that there's a easy way around it other than maybe like doing a binary search. We'll do a brute force search to begin with, but like there's probably like a way to do a binary search to find the right frame faster. We'll start with what's easy. range. And here we probably will need the refer to this array frequently, so let's grab it out of the dictionary. Peer frame size. And we want to say if time is greater than peer frames I data get start time 0. Hang on, so I think we want to do this the other way around. If the frame we are looking at, if its start time is greater than time, then we want to return the last frame, the frame before this one. So maybe we'll say something like frame equals peer frames. I'm trying to think of a clever way to not have to do a lookup here. Last frame data. So frame equals this, if then return last frame. Otherwise, we say last frame equals frame. And return null if we find nothing. Okay, so this should theoretically find the frame for the peer that is just after the time that we give it. Is that right? So if the frame we're looking at has a start time that's greater than time, no, that's backwards. Hang on. If time is greater so we're going to loop through the frames. Each frame, we're looking at its start time. We want to say, is this start time greater? Right. Okay, no, okay. So we want the frame whose start time is just before our the time that we're giving it. So if this start time is greater than time, then we give the frame before it. Does that seem right? Oh my god. I guess we'll find out. So let me rearrange this code a little bit. I kind of like those two methods being near each other. Separate this one down here. Let's go see how we're doing this. So we need to get a frame. For this peer ID, for the time that we're giving it, and if frame, then we'll do this, except frame type is the frame data get frame type. Otherwise, it kind of sucks that I have to do a separate line of code, but I just want to see if this works. We'll make this part saner some other time. Because we're running out of time. Wow. You know, when I'm picking stream topics, I always think like, oh, this will be good. And sometimes it turns out good, and sometimes it's like we're just like manipulating arrays and dictionaries for 2 hours and not getting to anything fun. I was really hoping to work on the data visualization side of this, and we are not. We're just trying to get the data in the right place. And of course, that's just the nature of making things, right? You never know what exactly is going to happen. We should have maybe worked on the stun client. Even though that's like a really weird technical topic that probably a lot of people wouldn't totally understand, but we at least would be like doing things and getting in there. Okay. Is any data coming through? Any data at all? No? Okay, where is this going wrong? Set some breakpoints. I just want to make this like do a thing, really. Let's have it show frame data based on time. Oops, I keep launching the wrong thing. I actually just realized the problem that this has. We need to look for log data start time plus the time that we are looking at. That is a thing. Let me just see if that was the problem. Probably should have only loaded one log. Oh, hey! All right, on the 8th millisecond, Peer 1 has a tick. When does Peer 2 get into the game? Just keep going till Peer 2 does something. Come on. Come on, Peer 2. There's no way that 100 milliseconds into the game. Oh, here we go. I guess there was just a really delayed start. Took 85 milliseconds until now Peer 2 is doing an interpolation frame and Peer 1 is doing a tick. And keep walking this forward. And it isn't nearly as slow as I thought it would be. Now we've gotten to some interframe stuff. They're both doing a tick. Okay. Wow. Okay. This is starting to feel like it could, like we're getting useful data. We're only seeing like one thing at a time. If we could see a whole bunch of things, then this would start to, the power of this would start to come through. And for that, we're gonna need like a much nicer way to get this data. Yeah, because we wanna be able to sort of like compose a whole row at once for a single peer. So let's say like we need like row, and we need to loop through the peers. And or row the right way to like think of it? It's a column, really. And so then we get the frame for that particular time. Well, yeah, we want to generate a whole column worth of data in each loop iteration. Say if frame, well, so if not frame, then continue. Otherwise, we're going to pack this column with everything we care about, which let's do what do we care about? Just trying to think of a way to do this fast without like totally hard coding stuff, because I just want to show how cool this could be. Say column, we're going to put tick equals, we'll say frame data get tick call, well, frame type we actually need. We need frame type at the top. Call frame type. We can copy this code once I so frame type the tick. What other data do we got? What other data do we got? We have a skip, true or false, with a skip reason. We have a duration. Let's just throw those three things in there, and we'll see what that looks like. So that was skipped, skip reason. Skipped reason. And we'll put duration up here. Okay, and then we need a list of all those things. I'm just gonna quick throw it together because we are totally out of time, I think. Yeah, I'll see if I can do this in like 3 minutes. If it takes me longer, then I'm gonna give up. Come back to it off stream and show you guys the end result. But I just really want to show at what point this gets powerful, because I think it does, especially once we turn the data that we're outputting into not just like words and numbers, but into a visualization that we can see. I don't know. Copy this. And then we'll say for peer ID in log data peer IDs, if not call. Okay, wait, we'll say if call has peer ID, then we do this again, but with the value for them, which would be call peer ID. Okay, else code plus equals an empty cell. All right, and then I think I can get rid of this. And I think this will output all 5 of these values that I just randomly picked. Let's give it a try. Yeah, it's like I was saying earlier, like I knew I should have been working on this last night to to advance the state of this. Like maybe the stream would be better if I had done more of this data mangling like beforehand, but I was just obsessed with making that stun client because I would love to be able to use that for peer-to-peer eNet in Godot 4, which maybe we should have done that. Maybe we should have worked on peer-to-peer eNet in Godot 4. Okay, here we go. Why is there no frame types at all? There's nothing. It's not showing us anything. What did I do wrong here? Okay, so columns, if not frame, continue. Oh, because this is just wrong. Call should have peer ID equals. And then, okay, you know what? We'll do calls, so I don't have to rewrite all this code. And then we'll do var call equals this, and then calls peer ID equals call. Maybe next time we'll do peer-to-peer eNet, because I'll probably have the stun server done by then. I'll probably have the stun server done by tomorrow. But then we could experiment with doing some non-WebRTC based peer-to-peer networking in Godot, which would be really exciting. Because I love WebRTC, but I also hate it. Like, it's so complex and has so much stuff baked in, which is awesome. But then it's so complex and has so much stuff baked in, which means like it'll do weird things that I don't entirely understand. And then I have to come up with ways to like trick it into working the way I want. Okay, look at this, guys. Let's get to where we start seeing two things happening at once. Come on. It takes 86, I think we said last time, milliseconds. Here we go. So now we can see at 86 milliseconds into the match, Peer 1 is running tick number 1, and Peer 2 hasn't run any ticks yet. The negative is actually part of the way that the library implements input delay, because there's a configurable input delay, and I think the default is 2 frames. So it would start on -2. Then we have an interframe event on both of them there for some reason. Then we get to the -1 tick and tick 2. Let's get to where we're seeing some actual ticks on both sides. And some interpolation frames. Okay, here we go. Tick 3, interframe. Why aren't we seeing interpolation frames? We should be seeing an interpolation frame after every tick. Instead, we're getting interframes after every tick. That's really weird. Anyway, this, I think, could be so powerful. We're seeing at this moment in time, 211 milliseconds into the match, Peer 1 is executing a tick. It's tick number 5. It took 8.675 milliseconds to happen, and then of course this skipped stuff, which would probably just not even be shown if like the frame wasn't skipped. But that's, you know, some sophistication that this tool doesn't have yet. And we can keep scrubbing through the match. And I'm envisioning, rather than showing this as just stupid data here, we could see this as big striping charts showing, you know, the different durations as like a line. Like if we're put rollbacks in here, the number of rollbacks at a time. So you could, if we have any more of those death spirals like we did before, where you would see like a huge spike in rollbacks leading to a huge spike in frames taking longer, meaning that fewer frames were leaving that client to get to the other clients, which was leading to a desync. Like all of that stuff should be something that we can point our eyeballs at and see some lines and colors and hopefully be like, okay, that's exactly what's going on here, as opposed to in the past where I'm like divining from chicken bones. What could possibly be happening here? Let's tweak a couple variables, see if it changes something. So that's kind of where this is going. And I'm sorry that we did the boring part on stream, but it was still great to chat with everyone, get back into the swing of streaming. Maybe I'll do like another off schedule stream to like kind of catch up on the weekend or something. Maybe I won't even announce it. Maybe I'll just do it and see who's around. and maybe we can jump into doing some other cool stuff. And hopefully next week, because I know I can't stream this Friday, hopefully next week I'll be able to get back into the normal swing of things. We can start doing some play testing and all of the fun stuff. Anyway, thanks everyone for coming. Have a good Thanksgiving week if you are in the US. Take care. See you guys later.